Good afternoon. This is better, huh? Good afternoon. My name is Floorke Spijn. I'm working for the Netherlands Space Office. And it's a pleasure to be here in front of all of you. A very extensive, in-depth program that the EU OpenGeoHub has designed. So it's also a pleasure to have some space here in the afternoon. And as a former citizen of Wageningen, I went to high school here. I also hope that you have time in between this busy program to go outside, because it's always also beautiful outside. And outside, or what is there as well, is also a theme this afternoon. Because as you all know, there's lots of EO data available, which are all turned into information. But what happens actually with that information? That's where this afternoon is designed for. We have many very interesting speakers amongst us who are using EO data on a daily basis in practice. From SWIR, we have Jacco de Jong, Arjan Krinse from iSpatial Techno Solutions, Gijs Simon from Future Water, Daan Molleman from SkyGeo, Parja Pasha from University of Twente. We have Aticia Loganathan from the Statistics Netherlands and Frank Helmich from the Royal Netherlands Meteorological Institute. They will talk a little bit about their organization, their company, respective university or government organization, and what they're doing with EO data. And then we have a kind of interactive session here, and then we'll go downstairs with all of us to have some drinks and chat more on the topic. So I would like to invite the first speaker, Jacco de Jong.
Yeah.
Yeah, you are there.
I'm there. Can I have a slide clicker?
Yeah, you can go into switch.
First of all, I'm very happy to be here. It's a pleasure to intermingle with you. I was in academia once, very short career, not for me, but I like research, especially fundamental research. I still follow a lot of it. So, can I? Oh yeah, yeah, sure. Yeah. So my name is Jacco de Jong. I'm a co-founder and CEO of Sphere, which is a startup in the Netherlands, and oh no, you made a PDF. Yeah, there's videos in there. Does a PDF run videos? Okay, that will not work. Can I grab my laptop, maybe? Okay. Sorry.
Second.
Deze kan je dat omwisselen. Weet waar ik moet doen? Dat kan ook.
That's why I never agree with having my slides copied to project. So always bring your laptop.
Send it to them last minute, then they cannot do anything.
I can go like this.
Ja, dat.
Thanks. All right. Sorry for that. My name is Jacco de Jong, co-founder and the CEO of Sphere. We're up there. So at the location there, that's Groningen. It's a small but fine university city in the north of the Netherlands, like 250, 300,000 people, I think. And what I want to show you is how we are trying to unlock the power of Earth observation for everyone, literally everyone. I'm not alone here. Carlos, can you wave? So Carlos is one of our small team. We're 8 people now. And I brought Carlos because he's our first international hire. So he's in an import, let's say, it's from Ecuador. So maybe he can give you a perspective of finding a job in the Netherlands, how that works. So if you'd like to discuss that, feel free to talk to Carlos. We have worked with Sentinel-2 data, so open source multispectral data, for years. And this is one of the downsampled data sets that we use of the north of the Netherlands, where we have been monitoring a specific type of grass, because it's a biodiversity indicator on the salt marshes, very custom. And before, we used to make a custom model to monitor that, so that province of Groningen knows how the biodiversity is doing on their salt marshes. But what we are specialized in is taking multispectral videos, let's say. So it's not so much computer vision, but more video analysis on Sentinel-2 time series. And so this slide, I think we all have in common. We study the Earth, and I don't have to tell you that the Earth is the one resource that rules them all, right? So a recent estimate by PricewaterhouseCoopers says that they estimate that almost half of the world economy is highly or moderately dependent on nature. And I have some examples here, which are in trillions of euros. So food, water, tourism, etc. There's many more. And some of them, which are harder to estimate, for example, clean air, aren't even in there, right? So Earth service and the way we treat it is important. I mean, no-brainer. And for that reason, we think it should be the case that everyone, each organization, should be able to use Earth observation in their spatial information gathering, not by a third party, but themselves. So as least obstacles as possible. So to reach that, usage of Earth observation data should be real time. So, and I mean not recent info, but the interaction should be real time. I have a problem now. I want to discuss with someone or some entity about my problem, and I need information back within a day, not within half a year, not within a month, within a day. Those insights should be scalable, ideally to whole countries or continents. It should be fast and cheap, as custom as I like. So not only leaf area index, but also a very specific type of plant I'm looking for. And ideally something that I need no prior knowledge of either Earth observation or AI. And I'm saying AI, I'm introducing AI here because we are an AI heavy company. We think that AI is one solution to the desired customness, right? So AI models can fit any function. They are very versatile, so they can be an answer to a very varying demand on indicators on the ground. What are the obstacles in the adoption of GeoAI? We already saw some, right? So Mark nicely introduced what their users or their organizations see as blocking. And he said management and accessibility. We see some others which are more technical. So to train AI models, you need good label data, right? And good label data is scarce. So last year there was in the Netherlands the AI for Copernicus conference. And one of the common problems that you hear there from academia, but also from governments, from commercial parties, is I lack the proper label data to use AI. Another problem is that developing and running AI models is very expertise heavy. You need infrastructure people, you need app development people, you need AI engineers, you need many different people, so a whole technical team to run proper AI models. And that, if you can find those people, it's very expensive and it takes a lot of time. It's slow. So creating custom models takes weeks, takes maybe months. So that's blocking. So the solution is easy, right? We should create AI that is fast, that needs only a little label data, and make development so easy and robust that anyone, literally anyone, can do it. And then I'm convinced that if you take away all of those obstacles, that management and accessibility problems will disappear. If you make the barrier really low for people to experiment with AI models, they will get a grasp. I mean, we've seen what happens with language models, right? If you put it in people's hands, they will experiment and the barrier will go. So we see as a solution foundation models, as generalized EO processors. So the old way of thinking in AI is you take a deep learning model, you take many examples, those are on the left, label data, and the corresponding Earth observation data, which is very little typically, because you have not very many good examples, and you train a whole model, and then you have customized it, you have validated, and you can run it for that use case. But if you have many use cases, you need to do this all over again. The new paradigm is, and that's what we saw in language models, is first create a model that is generic, that learns only from the raw data, so no examples. How this is done goes too deep for now, but I happily talk with you afterwards. But basically, instead of supervised learning, you need self-supervised learning. You need a trick to make the model get information out of the raw data. And suddenly, if you're able to do that, you're able to use all satellite data available to you, instead of only those tiny pieces where you know something is happening on the ground. And if done correctly, that model will get some general Earth intelligence. And what comes out are embeddings, and I'll show you very quickly how that looks. So we made such a model for Sentinel-2 last year, and this is an aerial photo of the Dutch salt marshes, and on the right is the embeddings created by our model. And actually, they're 128 size factor, but if you bring that down to 3, you can visualize it in red, green, and blue, and then you see that there's some coherent information. It's abstract information, but the model has learned how to look at the whole year of Sentinel-2 data and say something about what's happening on the ground. It's abstract, but it's high intensity or high information density. What we then can do is take that and make a platform where users can interact with that foundation model and train tiny models on top of it for their use case. We've made such a tool, and we call it Carto. And it's basically a web platform for people to fine-tune our foundation model to many examples. And I'll show you a video that shows you how that works. So in Carto, and sorry for the bad quality, by the way, I'll have to make a new video. It lets users create spatial monitoring in their browser without any knowledge of AI and EO. By just providing some examples, train a model, and then within a minute, or maybe if you have a slightly larger or more complicated use case, it's maybe tens of minutes, you get maps back and you can iterate on that. So here, you can use it for specific vegetation, or for here distinguishing loose standing trees from like vast forests. This is mangroves on Bonaire, so in the Caribbean. It's being used now by many governments in the Netherlands and some international parties for a vastly different array of use cases. We're luckily not alone. So we're in the frontier of creating foundation models for Geo AI. We released a prototype last year, September. So we're now actually a year old and have been iterating on our first attempt, which crashed on the first day, of course. But this year, when colleagues went to the Living Planet Symposium, which is a large EO symposium on ecology, geospatial foundation models were the buzzwords. And also Google Earth Engine was there presenting their embeddings, also based on Sentinel-2 and also Sentinel-1. So we were a bit nervous, but also we saw that, hey, if the big guys are moving in this direction, we took the right direction. Once they published their embeddings, we took them, we put them in our system and saw how do they compare. And I was very relieved to see that we compete with Google's embeddings. I think we have a lot more spatial quality, yeah. So we're doing something that I think is valuable. We're figuring out who can get value out of our foundation models. That's oh yeah, that's my time. So to conclude. I would be happy to discuss with you use cases or careers or whatever. We're always looking for talented people in either Earth observation, AI engineers, software developers, or ecologists. And also, I think our embeddings could be very useful for researchers to speed up their research. We can start collaborations. So we currently have a nice collaboration with TU Delft that's running for 3 years, because Right now we're focusing on Sentinel-2, but that's the beginning. We're in the coming 3 years planning to expand that across many data sets to improve the intelligence of our system. Yeah, and always looking for interns, employees. If you are interested, you can go to our website or contact me at contact@sphere.ai. Thanks.
Thank you so much. Can I hand it over to Arjan? When we're waiting for a little bit, what would you say is the biggest asset in your company?
Biggest asset?
Yeah, is it like the
Well, our
algorithms or the knowledge or the?
yeah, it's the team, right? So the people matter, but it's also so the fact that what we really keep secret is the way we train our algorithm. So the self-supervised learning algorithm is really different. We looked into what Google does. We took a completely different direction, and that's the secret sauce. That's what we keep secret. We tried to patent it, but that was a very bad idea, because then you have to open it up, and basically everyone can use it, and it will not show up. So it's hard to maintain. So we're keeping that secret. That's our advantage right now. Yeah.
So, hello everybody. I'm Arjen Krinsen from Spatial Techno Solutions. It's a 15-year-old company. I started working with them about 10 years ago, on and off as a consultant. And this year we decided to come to Europe and expand to Europe as well. And yeah, so I'm very pleased to be here. So we have a lot of products. We do a lot, also general GIS solutions, but also Earth observation and GeoAI. Sometimes it was difficult to say, okay, what shall I explain here, and what are you most interested in? So I'm looking at your faces as well and see which slide you like most. But I guess this one is too much information for you now, except when you want to work with us. But that's another, happy to discuss that later. So the question was more or less why open data matters. And I think the foundation for GIS, since I've been working with GIS and Earth observation for 25 years, the open data really matters. And it's a foundation for a data-driven society. And it differs over the world, as we have experience in the Middle East, but also in US and with the UN. You can see, I think the EU has created a really strong drive for open data, but also the right regulations and the right standards in order to be able to use it globally and make it interoperable. How many of you know Inspire, for example? Okay. There's a lot to learn, but I think all those the foundation and those kind of things will matter in order to go from the policies, which normally the governments are making, to the source data, which can be raw imagery, which you can use like Sphere is using in many great products. And then it goes to a data product, and to that to an information product, and then resulting to insights. And from the insights, you hope that if we present it in the right way, the policies will change and will make things better in the whole world. And that's a basic thoughts which we try to imply with all our products and enable to use the data correctly and get to the next step. And yeah, everybody knows about the data silos. Again, data is going so big. When I started 25 years ago, Earth observation and the resolution was not that great, but you still could do a lot with it, making models. But then having them real time was still not an option. But nowadays it is an option, and there's far much more possible. But now the silos which are there with all different information, sensor data, spatial data, finance data, we have to combine that in order to give the right insights and to make a real change in the society. And then the next step is, how do we do that? We try to make some nice workflows which we can use and which we can generate and we can use them at different clients in order to generate the products they want. It's a nice slide, or not? I'm just trying to keep you awake. This is an example which we're doing for a municipality in order to give a lot of insights to check their data with current Earth observation data. This is really making an impact in their society, and it will change the way people are looking at it. You can also see, you can look at it, we're surveying too much. Maybe that's another side of it, but it makes the society more safe, and hopefully it will help also with a lot of the problems in the society. This is another one with solar panel detection in the US. Net congestion, which probably is, as you know, is a big problem everywhere in the world. You can solve part of it by combining the data from the network utility companies with AI solutions. So that's how we're supporting them and helping them out. This is another nice product, classifying parking spot occupancy. And this is what you need real time. There's no point in doing that, of course, the day after. So depending on the product, you either need real time or you need to be able, you have more time in order to generate products or to generate models to predict any of the solutions. Super resolution and satellite imaging, enhancing the geodata model accuracy. That's something which we do as well. And it will help in order to see more, as you can see on the images. Is that something which you learned this week as well, or not? Or were you already aware of it? Anybody? Yeah? Okay. So you're all aware of how to do this anyway? Yeah? You're getting there, I guess. Then this was a really interesting product from the UAE. It was their 50th birthday, and they wanted a national map of all different teams. And by generating that was kind of difficult, because there's also a lot of proprietary data. There's a lot of AI generated data from Earth observation, and how to combine that in a proper way that you don't put too much of the GDPR data out there, but you also make it insightful and you have some nice statistics. I guess from the Statistic Bureau, we can learn a lot, and you'll hear about that later. But we found this model in order to give the right insights, but not to give too much insights. And let me conclude on, by using open data and apply the location intelligence and AI, we generate a data-driven society. That's about what I wanted to tell you.
Thank you so much. Gijs Simons, can I give the floor to you? Yeah.
Good afternoon, everybody. My name is Gijs Simons, representing Future Water. I'm here with Tijmen, right there in the second row, also part of the team, actually based here in Wageningen, with our head office right around the corner, you could say. Very happy to be here today and to be able to present some of our experiences in using Earth observation technologies in our work. And our work mostly relates to water resources management, as I will explain. So we are a company that focuses on research and consultancy and the interface between those two aspects. Working on innovative solutions, innovative projects that support a more sustainable use of the Earth's water resources. Our core expertise lies in the application and development of spatial hydrological models, use of Earth observation to enhance those models, GIS technologies. And ultimately, we serve our clients who mostly come from the public sector, also from organizations like the World Bank, Asian Development Bank, different NGOs. So all kinds of actors in the water resources management landscape, you could say, who are interested to take the right decisions that serve their objectives. We work globally from our office in Wageningen and our second office in the southeast of Spain, in Cartagena, as shown here on the slides. Quite a lot of countries are colored in here, but I would say our focus regions currently are Central Asia, Southeast Asia, Sub-Saharan Africa, and roughly the Mediterranean region, so still quite a wide reach within our current projects. So within our work, we use Earth observation, as I mentioned, quite intensively at a daily basis, definitely, in different ways. So when thinking about this a bit more carefully, I came to a number of different applications that we typically have for Earth observations. First of all, in our consultancy services, so these are really studies that lead ultimately to reports on water accounts, on the water resources situation, on ecosystem services, irrigation performances, those kind of more strategic studies. EO is typically a very important input because of the fact that it provides you spatial information that transcends political borders, that can cover areas that are remote or that are typically lacking certain data from ground-based monitoring systems. Also, we have more operational decision support systems relying on Earth observation information in a more dynamic manner. So there we update our services daily, weekly, monthly, depending on the need of the client, based on the newest or the most up-to-date Earth observation information. And then the second bullet relates to the modeling, the hydrological modeling that we do. So there, Earth observation comes in potentially as an input. So of course, there's a wide range of input variables that can be captured with Earth observation. Those can be dynamic, like precipitation or land surface temperature, but also static parameters of the model, such as land cover, topography, soil properties, all those things that you are probably all very familiar with. And then secondly, apart from input, it can also be used as validation or calibration data. So an independent data source that provides also, in addition to the model output, also on the same variable, some estimate that we can use to see if the model does well, if we need potentially to calibrate certain parameters of the model. or even try to assimilate the data into the model, which can be possible in some cases, but also is a bit more advanced. So in some of our projects, that's just beyond scope. But in more advanced applications, that is definitely an option. I will now give 3 different examples of Earth observation applications in our work, just to give you a rough idea of the kind of activities that we have and how Earth observation provides added value to us and to our customers. First of all, on drought early warning, Future Water has developed a drought monitoring and forecasting system called InfoSequia. So sequía is drought in Spanish. This system has been implemented now in a number of countries. Currently, we are active in Colombia, Somalia, and Pakistan, in, I would say, quite a varied range of applications. So in Somalia, for example, we are working with the World Food Programme on trying to use this system to provide early warnings on potential food security issues. In Pakistan, it's very specifically aimed at flash droughts, so very rapid and severe drought events that can occur when heat waves coincide with a lack of water in the soil and a lack of precipitation. And in Colombia, we serve regional water managers with this system to provide them the latest information on especially the impacts of hydrological droughts on the vegetation and agriculture in the area. Basically, Earth observation comes in here in 2 different ways. So as you can see here on the slide, there is a monitor module as part of the system. So this relies very much on vegetation indices and temperature-derived indices of drought impacts. And there's a forecasting, it's actually a seasonal forecasting module, which brings in a lot of different types of inputs, but Earth observation is definitely an important one. And a machine learning approach is employed to train a decision tree-based model involving also Earth observation data sets to provide seasonal outlooks of potential drought impacts. So seasonal in this case means up to 6 months ahead. And this is then a screenshot of the application we did in Mozambique. I will not go now into too many details, but please feel free to reach out in the networking later if you have any specific questions on this one. We also brought some flyers actually about this service. Then another very different setting, a very different application we developed for the Mekong River Commission, which is based in Lao PDR, and it has 4 member countries, basically the nations that together make up the lower Mekong basin, so Thailand, Vietnam, Cambodia, and Laos. And they have an interest to keep track of certain environmental indicators that they want to map across the entire river basin, one of which is the extent of salinity intrusion. And they currently, before this assignment, they lacked the capability to really make this a regular monitoring service with spatially continuous information. So there were just a number of station locations where they had data for in the delta, the Mekong Delta. So based on remotely sensed salinity indices validated with ground truthing in the field, we set up this workflow in Google Earth Engine, which was a request that they had to do it in Earth Engine because they were familiar with this platform. So the idea was also to really transfer this methodology to Mekong River Commission so they can regularly apply this as a monitoring approach. And based on this methodology that was developed, we were able to derive monthly maps of salinity concentrations, of course, since the start of the availability of satellite data, in this case, the start of the Landsat 5 satellite. So As you can see here, there is we managed to produce with this methodology these seasonal maps of maximum salinity intrusion in the delta based on monthly images, and the blue and the red images in the middle and on the right, so that show then the area that have an exceedance of a certain critical threshold level, depending on the requirements of a particular water using sector. So they work with thresholds for example, biodiversity, for human health, for agricultural use, for irrigation. So based on the difference in sector, also different threshold levels apply. And these extents were then mapped and monitored in their reporting infrastructure. This is for a particular location in the delta, showing the blue line with the salinity concentrations and then the horizontal lines with different threshold levels. And then finally, also another operational service that we are currently running using also Earth observation in combination with water resources modeling. This is the GLOW tool developed by Tijmen, among others. So this is currently being applied in the southern African region, especially in the Umbuluzi and Maputo river basins, where we aim to support the regional water managers to have up-to-date information on water availability in reservoirs. So here we combine water availability in reservoirs from both modeling and Earth observation using altimetry data with water demands in the area with a spatial water resources model. So this is an example of what this then looks like in a spatial map, where the dots show the extent to which the reservoirs are full at a certain point in time based on Earth observation and modeling. And then the forecasts in the bottom right show, when you relate these figures to the demand, expected demand of the different water using sectors, depending on these reservoirs, how the storage will probably go down or go up over the next weeks. So that was the third and final application that I quickly wanted to highlight. So please feel free to reach out later on those or any other questions you might have. So thanks a lot for your attention.
Thank you so much. And now Daan Molleman from SkyGeo.
Good afternoon, everybody. I'm Daan Molleman from SkyGeo, all the way from Delft. And I would like to start you off with a raise of hands. Which one of you has already heard of INSAR? Okay, not too bad, not too bad. And the ones that don't, have you heard of radar satellites like Sentinel-1? Okay, another great show of hands. Good. So what we do at SkyGeo is we use INSAR to do deformation monitoring. So this technology allows us to detect millimeter changes in the ground surface or objects or anything else basically that has a good radar reflection. And I'm going to keep you guys awake with another raise of hands. So how many of you have heard of the Westerkerk in Amsterdam? Ouch. But how many of you have heard of the Anne Frank House in Amsterdam? Yeah, way better. So that's right next to it. This picture is taken basically from the Anne Frank House. So if you've been there, you've probably seen the church as well. And today I want to talk about the city of Amsterdam that monitors this church. So they have a couple of leveling bolts on there, which they take measurements of from time to time. So every couple of years they see how is this church doing, because of course Amsterdam is built on these soft soils, right? And big old structures like these don't always hold up the best. And one day in 2021, they took another measurement, which kind of shocked them, because they noticed that from their data that said that from 2011 to 2021, the church moved a whopping 31 centimeters and was tilting towards the canal. And this meant, if this is true, that the church was about to fall over. And if you've been there, you know this is a really busy touristy area. There's a lot of people going around there. And if this is true and they need to really fix this, they would have to open up the ground, fix the foundation, and it would probably take a couple months and a couple million euros. So they really didn't want to get into that. So they called SkyGeo, basically with the question, guys, we know you do deformation monitoring. You can go back in time. Can you please tell us what's really happening? So basically a second opinion, like when you go to a doctor and they ask for a second opinion, that's what we did. And we got to work. What you see here is top-down view of the church. You see thousands of colored dots, each having hundreds of measurements through time at a millimeter scale, which allowed us to really see what was going on through the years. And what we noticed is this church wasn't really tilting 30 centimeters towards the canal. There were some difficult statistics going on. There was some filtering. How high is the point? What are we exactly looking at here? And what we got from here is, oops, too fast, was that it was only moving a mere 1.5 centimeters towards the canal. So this meant that the canal didn't have to be opened, that the church foundations didn't have to be renovated, and that the municipality actually saved a couple million euros just by calling us. Pretty good, right? But as SkyGeo, we don't only look at old churches in the Netherlands. We look at way more, because as with Sentinel-1, you can look at the entire world. So I'll go rapid fire through some cases that we do. And let's say we do new tectonics in Iran. It's a pretty large scale project. What are the tectonics doing? How is it affecting the local people? We do dam monitoring in open pit mines. You don't want this wall to come down. We do utility monitoring. Is it infrastructure? Is it gas lines? We can see it from space. And of course, we do more wide-scale analyses. I guess a couple of you may recognize some patterns here, especially in the Northeast. But if any of this is sparked your interest, if you really want to work with this kind of stuff, then come talk to us after this downstairs. Thanks.
Thank you so much. Next one is you, Pasha.
Good afternoon, everyone. Do you hear me right? I'm going to shout anyhow because I'm going to get excited when I'm talking and I'm going to speak louder and louder. So I will wake you up. So first of all, my presentation is a bit different than the others you have heard and the ones you are going to hear, because when Coco from Space Office asked me if I can join today, she asked, would you be interested in giving an inspirational talk and share what you have been doing in the University of Twente with Marmoris and in the Space Campus? So I really thought, how can I make it about myself? So making it about myself, I thought of giving you a talk where I tell a little bit why did I end up having 3 jobs at the moment. And by doing that, I also tell you what we are doing in each of them. So I have a mini presentation of ITC University of Twente, couple slides about Space Campus, and couple slides about my startup. So I hope that each of them can kind of relate to some of you, because you from here you look like a very diverse group. Should I do another hands up exercise? I'm really genuinely curious. How many of you are doing MSc or finishing MSc? Wow. How many PhDs? Holy. All right. So I already apologize for anything illiterate that I'm going to be saying, because I did not do a PhD. But fun fact, this week is exactly 15 years since I moved to the Netherlands. I moved to the Netherlands to do my Master of Science in Geoinformation Science and Earth Observation at ITC Faculty of University of Twente. Before that, I did civil engineering. So this is a story of how I went from an actual engineer to someone that people would say, what does she actually do? So it is mostly talking, budgeting, lobbying, partnerships, finding relations. So that is how I lost that touch. And it is unfortunately more than 7 years that I have not written a single line of code. But there was a time that I was teaching databases, geoinformation science, and Earth observation at ITC faculty. And then slowly I moved to project coordination, project management, and I took a different position, helping academics securing funding and looking for, let's say, building up their consortium, finding funding that can help them get more PhDs, get more budget for capacity development. And from there, I felt to myself, okay, is this how my profile is developing? So am I completely saying goodbye to becoming a scientist or an academic? And then I started working part-time in a GIS consultancy company to see if I like the private sector or not. While those were going on, COVID hit. So while I was deciding what I want to be when I grow up, COVID hit. And then there was a hackathon that was organized for a coral reef conservation organization in Costa Rica. And the question they had was, can you map the sedimentation in water using satellite information? Because they needed that for planning their nurseries and planning their intervention. So while everyone was baking bread, my colleague from Gespecialisten and I, Samantha and I, started doing a hackathon, and we won the hackathon. And as a result, we were invited to submit an application to European Space Agency's business incubation program. And guess what? We won that as well. We got accepted, and then I had to make a decision. Do I want to have a company? So is there anyone from you who wants to have a company or wants to be an entrepreneur? Okay, don't be shy. I mean, you can also just like it. Doesn't mean that we're going to throw you to starting your company tomorrow. For me as well, it was, for me and Samantha, the most important question was, why do I want to have a company? It was not about being rich, because to be honest, there are much easier way for being rich than using Earth observation. Right, the company guys over there. So it was about really, the fact that was important was, we know GIS remote sensing, satellite Earth observation can offer so much. And there is abundance of data and information out there, but the end user either doesn't even know that it exists or don't know how to use it. I mean, and I always just throw myself as an example. I have a background in GIS remote sensing, but now if I have to read like from Copernicus Marine Services, do a time series analysis to find anomalies, I don't say it's impossible, but nearly impossible. It's going to take me weeks to figure it out. So imagine someone doing coral reef restoration, how difficult it is for them, even if they are marine biologists. So our driver was that. Let's see if we can use Earth observation for impact, and let's see if entrepreneurship is a way to do that. So in the meantime, while I was busy with that, I also within the faculty started getting a bit bored by only supporting the proposals. So I got a new position in the faculty bureau, and I started looking more into faculty's strategic partnerships and external relation. How can we work with the government? How can we work with industry? How can we also be more visible, let's say, in the Netherlands and Europe. I'll tell you why that is important. And to be honest, there was a very, very nice overlap, because while I was doing my startup, I was getting to know more companies, getting to know how it works, getting to know how you can have partnerships. And through that, I met the people from NL Space Campus, and we started doing a project together. When we were doing that, after a couple of months, they offered me a job. And because I cannot say no to anything when I'm excited, I said, sure, I'm going to fit a third job 1 day a week, and I will work with them. I can gloat a lot about it, but the only reason I can do it is because there are so many synergies between this. So the topics are pretty much the same. The ecosystem is the same, the fundings and grants. So it really helps me to have network from each of them and bring experience one to the other. But now to tell you about each of them a little bit in short, you can look up for more information or you can come talk to me. But to begin, as you see, 15 years of my life in this faculty in Enschede in the Netherlands. I did not see that coming when I moved here. But it has been a very, very, very nice journey, because ITC faculty stands for bringing the geoinformation and Earth observation for solving global challenges. So we have 75 years of track in doing institutional strengthening, in global development cooperation, and in education all around the group. We started as a training institute. That's why it is called ITC, like International Training Center for Aerial Surveying. But then we became a faculty of University of Twente, but we still keep our DNA in impact-oriented work, impact-oriented research, education and capacity development for solving the world problems, the wicked challenges of the world. And we are very, very proud of the alumni we have all around the globe, with more than 25,000 professionals. And of course, each of them also has the footprint of bringing geospatial for solving the problems. So in most of the companies as well, you either have had an alumni from ITC or some of our educational programs, or they want to work in your company. So it is really something to be very, very proud of for being a part of it. And with the companies now, as I said, we are looking for more academia industry type of partnership and work. So I will come to you guys as well, hearing now what you're doing, to see how can we push research more out of just university and bring it into product development and problem solving. Speaking of bringing things to real world, the other job that I have at the NL Space Campus also heavily focuses on this. So what I do at NL Space Campus is I am a program director for a European Space Agency program called VLab Netherlands. VLab is a program. It provides 200K seed funding plus coaching and network and connection and technical supports, with the idea of connecting research and innovation to commercialization. I say connecting because it is not supposed to be a technology push, but it is really making that bridge. So I find it also, again, very fitting to my entire point of pulling research innovation out of the desk and papers and making sure it reaches the end user for impact. The other project I'm responsible is supporting space entrepreneurial journey in the Netherlands. It's a partnership project. So again, it's to help space professionals finding their way in which they can do impact. And our Space Campus is a foundation located in Noordwijk. So I also have to commute from far east in the Netherlands to far west because of these two. But it is also very, very exciting to be a part of that, because we are building a space campus. We have the European Space Agency there, we have USPA there, the GRC Center, a lot of companies. And now we have a vision. We are building a campus and we want to be the kind of like the portal or the gateway for space innovation in Europe. So the budget comes from the government, partially from NSO through programs, partially from the municipality of Noordwijk. And the vision we have is to create this space, pun intended, where you have the students, businesses, researchers that work together, work with ESTEC and USPA, and create innovative solutions for a safer and more resilient society. One last thing about what I do there, and the VLab coincidentally, one of our thematic focuses is Earth observation. I have to tell you, I had to jump through a few hoops because being in ESTEC, everyone thinks that innovation should be on the engineering side of it and the rockets, but Earth observation also has ample room for innovation, research, and commercialization. So if you have ideas about that, also come to me. And of course, last, my personal favorite, obviously, is Marmoris. So Marmoris is a startup that we founded during COVID following the hackathon. And that was fast. And we basically looked into coastal habitats and the degradation of these habitats due mostly human-centric threats and what we are doing to the environment. And knowing what is possible with satellite Earth observation, we wanted to bring these solutions to the end user in a way they can understand it, they can use it, they can retrieve the information that is needed for them. I know I'm rushing a little bit because I don't see there's a point in, that is a lot of animation. So each of you on the spatial analysis, you more or less would recognize these kind of like decision making. How can you fit your expertise in geospatial for decision making, right? We do baseline mapping, like habitat mapping in the case of Marmoris. We do time series analysis, for instance. You heard about the salinity monitoring. We look for anomalies and change detection. It could be in the infrastructure. It could be on the mangrove forest area, but mangrove forest extent. And once we know these things, we can get insights that are useful for making decisions by the government, by the policy makers, and it also helps them to see what type of interventions resulted to what type of impact. At the moment, we are looking into carbon markets, biodiversity credits, because I learned the hard way, to be honest. Now Marmoris is having its second life, because after the incubation and when I got the new jobs, it had gone a little bit to the back burner. But now we are picking it up again with new partnerships. And I learned in the previous attempts that it cannot be a charity, and I cannot just be like for good, for environment, for impact. I also have to think about the finances. And while I want to stick really to environmental conservation restoration, we also need to look into business models around it. So like my colleagues, I'm going to finish it as, if any of them has kind of like created an interest in you, reach out to me, find me on LinkedIn if you will, drop me an email, or just let's talk during the drinks and see if we can find each other somewhere else. Thank you.
Thank you so much. The second last speaker of today, Atatia, from the Central Statistics.
Hello. I'm Aditya. I'm from the Statistics Netherlands department, and today I'll just walk you through what we do with Earth observation in Statistics Netherlands. And a small synopsis about me: I studied at ITC, University of Twente, and my specialization is geoinformatics. And I've been working at CBS for like last three years, I guess. So let's move on. So CBS is Central Bureau of Statistics, but in English it's Statistics Netherlands, both the same. And it's an old organization established in 1899. And it has 3 offices: Hague, Haarlem, and Bonaire in Caribbean. And we have a lot of employees, and we produce a lot of statistics every year. And some of our statistics are published in NGR, National Georegisters, and some of them are published in PDOC. That is also widely available for other users in Netherlands. And for an instance, if you think about spatial statistics, CBS has been working on it for a while, but we were newly introduced to Earth observation recently. And the reason for that is this conference. So in 2021, DGIN conference held in Warsaw resulted in a Warsaw Memorandum. And major outcome of that conference is all the general directors of national statistical institutes, along with the Eurostat, encouraged that we have to invest on Earth observation-based statistics, and we have to establish a lot of communication between the existing NSIs, National Statistical Institutes, in order to make better collaboration and so and so. So that was a starting point where from CBS, we started looking into Earth observation data and how we can integrate Earth observation data into official statistics. So with that start in 2021, it took a time. So we started in 2022. So we applied for a lot of grants that is available every year through Eurostat and other organizations. And I can walk you through some of the projects that we are working on top of that grant. So for example, AI ML for OS, that is AI machine learning for official statistics. And it has a lot of work packages, and one of which is fully focused on Earth observation. So that is mainly to focus collaboration and making some interoperable models across the Europe. The second project is the GEOS 2023. That is a fully Earth observation based project. It has a couple of work packages like biodiversity, focus on biodiversity, and something that is focused on land use statistics, and something to make these kind of operations across the Europe. So it's a lot of lobbying and maintaining or organizing a hackathon or organizing a workshop, those kind of things. And next project is the NEVSAT. So this is majorly for the crop cultivation and crop classification that is in collaboration with the agricultural land management. And there are also other projects like EU City Grant, GEOS 2024, these are all grants that we work at CBS. And whenever that something comes up, we'll think about a problem that we are actually facing in the official statistics department and how we can mitigate that using satellites on Earth observation data. So it will go through a process and decision-making bureau, and then it gets to us. And for example, GEOS 2024, it's for detecting underground parking garages from satellite images and along with some stereotypic panoramic images. And the GEOS 2025 is basically based on socioeconomic data in collaboration with air quality data and also with crop yield statistics. So all of this is usually in collaboration with other NSIs. So we interact a lot with German NSIs, Polish NSIs, and some NSI from France. So most of the projects are in collaboration with other departments. So in regards to 2025, GEOS 2025, I'll give you a small backstory about it. In March this year, 2025, we attended a conference in NTTS conference in Brussels. And it was with a hackathon in it called Earth Observation for Official Statistics, where 30 plus teams participated. And the Netherlands team won the first prize. And the project that we did is the air inequity dashboard that is utilizing Tropomi dataset along with some socioeconomic parameters. So we got a lot of support from Eurostat after we won. So we put together a project that we can publish it as a official statistics. So that's how the grant made into picture. And next up, I'll slightly give you an update about what we do with these grants and what we do with the projects in slight brief. So this one is artificial intelligence / machine learning for official statistics. So the major motive of this project is to establish collaboration from the context of Earth observation data for official statistics. And 8 other NSIs, 8 other national statistical institutes were involved in this grant. And the overall idea is to come together in 2 different categories. One is crop type mapping and one is land cover mapping. So each of them prepare a set of models and set of methodologies, and they come together, compare the results, and then they decide which one to go forward. And once they decided the model to go forward, they try to make it domain adapted for other terrain regions, because, for example, something trained in Poland dataset may not perform well in Netherlands terrain. So we have to make them domain adapted. So they these models go through a process. So in that case, for this project, two of the models from are finalized. One is from the Poland, and for the crop mapping area, and the one for the land cover monitoring is from IG in France. So these two got to the last stage, and these two models will be further analyzed for making it adaptable for other terrains across the European Commission organizations. So this is a part of the work package WP7 of the AI/ML for OS project. And next one is GEOS 2023. That is another project that I'm currently involved on. So this is basically focused on land use mapping. So from CBS, we are responsible for creating the land use map of Netherlands every year. So it goes through an iteration every couple of months. We put together a lot of information from various national registers, and it's a different process. So in this case, we proposed a certain pain points that we are facing during our process and how we can mitigate them using satellite data and some deep learning methods. So this work package is majorly focused on finding construction sites for land use classification, because I can understand for land cover classification, it's pretty straightforward. For land use, we have to consider other ancillary data also. And second one is the built-up area mapping for the land use. That should be very similar to how we generate land use map from Netherlands. And the third one is the land use change detection. So that is also a new indicator that we would like to propose as a product from CBS. So all this works usually happens in the CDSC environment. So we mostly utilize open source data from Sentinel-1s or aerial photographs and openly available PDoc information, so and so. And all of them are properly logged in CDSC environment. So that is where our computational power exists. So for the initial pilot or something, we use the existing template of the CDSC environment. So when we feel like we don't have enough computational power, they have a different cloud storage, Credios, Credelia, and we would be having a space in that so that we can run some heavy foundation models or some Dino V3 models or something. So this is an overall overview of CBS and Earth observation data. And thank you for your attention.
Thank you so much. And last but not least, we have Frank Helmich from the Royal Meteorological Institute in the Netherlands.
Yeah, good afternoon, ladies and gentlemen. What I'm going to do today is I'm going to give a very high intensity presentation. So you have to take a look at this very, very carefully. So close your laptops. And why do I do that? Because I would like to finish with a quiz. And what you can win is the one and only KNMI Storm Umbrella, which you are going to need tonight because it is code yellow in parts of the Netherlands because of the heavy winds. So here we go. So we start with the beginning. This is Christophorus Buysballot. He founded in 1855 the KNMI, the Royal Netherlands Meteorological Institute. And we focus today on satellite observations because actually that is my job. I'm leading the department for the R&D satellite observations within KNMI. And I'm not here alone. We have two more people from KNMI. So if you would like to know how it is at working in the build, you can ask us, the people over there. So wave, please. Yes, thank you. So as I said, remember what I've said. Meteosat is one of the first things that I would like to mention here because we just had a launch of the Meteosat third generation sounder on the 1st of July of this year. But the first Meteosat was already launched in 1977. And there may be even people here in the room who have seen the pictures from that Meteosat in the news at that time. We're now at the third generation and things are going very smoothly at the moment. KNMI is the representative in EUMETSAT for the state of the Netherlands. And most of you have heard of ESA, but there's also EUMETSAT for the meteorological satellites. And EUMETSAT has since 2006 a polar system. So while the meteosats are geostationary, the EPS, the METOPS, are in a polar orbit. Now, these have many, many instruments on board. These are big, big satellites. And by the way, we just had a launch on the 12th of August. The METOP second generation A1 satellite was launched. A second one will be launched in a year from now. We have many instruments, as I said, but they also the B satellite to be launched next year has a scatterometer. And there are more scatterometers on satellites in the world. The Chinese have them, the Americans, the Indians, and the Europeans. And we process all that data to put it into the wind speed and wind direction above sea. And as you know, 70% of the Earth is sea. So there are not many places where you can measure it yourself. So what we do is we do it with satellites. And most of my colleagues here have spoken about land or sea, but the atmosphere is, of course, the terrain of the KNMI. Satellites are enormous importance for weather forecasting. If you look what ECMWF, the European Centre for Medium Range Weather Forecasting, is doing in its assimilation of data, almost all of it is, as you can see, it is the red part and the slightly, now all the red part is satellite data. That's what they use in order to do the weather forecasting. The best leap that we had is because more satellite data became available. So the forecasting has improved a lot because we have this beautiful system of all these satellites. And this is not only the EUMETSAT satellites, this is also the Japanese, the Korean, the Chinese, and the American satellites that provide data for the European Center of Medium Range Weather Forecasting. There are many, many satellites, and you see here free flows of satellites for Earth observations. You see on the left, you see the ESA satellites, which are mostly for science. In the middle, you see the Copernicus program of the European Commission, and that has been discussed extensively here already. But on the right-hand side, and this is less well known, you see the meteorological satellites. And we have quite a few of them within our program for EUMETSAT. Now, by the way, all these are built under the leadership of the European Space Agency because they are the only ones who can work with the space industry. But it's a lot. It's mind-boggling what you can do, but there's also a lot of work for you to do in the future. Now, one of the highlights which I have from my department is, of course, the Sentinel-5P, the Tropomi satellite, the Tropomi instrument. We do a lot of things with that. It is the first one in which methane can be detected in the atmosphere. And our colleagues from ESRON, there are a few in the room, do this mainly. We do the nitrous dioxide, for example, because that tracks climate and it is air quality. We have CO, what happens with biomass burning, and how does that translate into CO2 later for the climate. We have sulfur dioxide, mainly from mines nowadays, not anymore from industry, and many, many more things. And it all started for us with ozone. Tropomi is developed in the Netherlands and was under scientific leadership at KNMI. Now, I said nitrogen dioxide. What you see here is a picture that my colleague Pepijn Veefkind made of the emissions, or actually the concentrations, which happen over the whole globe. And this is an average, of course, over many, many months. But you see a lot of you see the industry. That's what you see. If there was no human activity, you would only see the forest fires. But here you can really see what mankind is doing to Earth. The good thing is, thanks to the European Commission, we already have a lot of reduction in that. So half of the emissions are only half of what they used to be more than 20 years ago. Now we do, of course, nitrogen dioxide, but we also do ammonia, but it's from a different satellite, and you can see what the impact is in the Netherlands. EarthCare is our newest project. We do all the processing, or we lead the processing, I should say, for the EarthCare instruments. This is a satellite of ESA, where you have a cloud profile radar, you have a LiDAR, and you have two imaging instruments, all working together to create a picture of what is happening in the atmosphere with clouds and aerosols. Now, what are the opportunities at KNMI for people like you in the room? Well, we have approximately 3 internships all the time. So, and these are 4 months. So if you have master's students which you think, okay, these could work at KNMI for 3 or 4 months, you can put in a request. We have possibilities for joint research, and we have possibilities for jobs, but there I have to say that it's only 1 or 2 per year in my department. And we have more departments, of course, so there is plenty to do. Now, we're going to start the quiz right now. So if you all stand up, if you can, of course. Okay, here we go. The first question. Was KNMI founded before, hand up, or after 1850? Yeah, do it now. Here comes the 1854. So those with hand down can remain standing up. The others, please sit down. We go to the next question. Where is the KNMI located? In the Bild, hand up, or Utrecht, hand down? Here comes. It should come now. It's in the Bild, of course. There's a direct connection from here to the Bild by taking bus 50. I just did it. Then the question 3. What percentage of observations are used by ECMWF for weather forecasting in 2020? Is this approximately less than 80%, hand up, or more than 80%, hand down? Okay, here it comes. More than 80%. Those with hand up, please sit down, and others remain standing up. It looks good. Tropomi measures many gases in the atmosphere. Which one cannot be done or not be done very well with Tropomi? Is this CO2, carbon dioxide, or is the CO carbon monoxide? Okay, here we go. CO2 cannot be done. We really have to wait for the CO2 emission of the European Commission, which will be fabulous, and the Tango satellites that we're currently building together with our Dutch colleagues. Then we go to the next question. How many years do we have geostationary images of Europe? Is this more than 55 years, hand up, or less than 55 years, hand down? Yeah, everybody has a choice. Less than 55 years. Okay, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, that's too many. NO2 is measured by Tropomi. But how would the world average map of NO2 look if there were no humans? Hotspots in Europe and Asia, hand up, or rather dull, hand down? That's, I'm sorry. It would look rather dull. So let's see, question 7. We have to move fast now. What applies to scatterometers? The signal is reflected by clouds, if present, hand up, or is reflected by land and sea, hand down. Yeah, I make it more difficult now. Scatterometers see through the clouds. So those with hand up, please sit down. How many do we have left? 1, 2, 3, 4, 5, 6, 7. Okay, we're doing well. Question 8. Is EarthCare KNMI leads the level 2 processing in EarthCare disk? For which instrument does KNMI provide the processor itself? Is that for the LiDAR, ATLIT, or for the cloud profiling radar? Okay, here we go. Those with hand down, please sit down. 2, 3, 4. Okay. So now we're going to have the real difficult question. So you have to shout. How many countries have EUMETSAT membership? So 80? 85? 27? 26? 40? 26 and 27 are closest because it is 30. So the 2 of you may stay. The others, please sit down. Oh, sorry, for one more. Yeah, too late. You can stay up because I forgot. Okay, there's another one. What's the annual benefit for to the EUMETSAT member states of doing these kind of satellites? I start with you. In millions or billions of euros, that's what I'm asking for. 80 million? Yeah. Gentlemen. 150. It is 52 billion per year. So I think you're closest. You win the umbrella. How many percent are you a stakeholder? We only pay the costs. So as I said, we had a very nice launch, and I just like to show this to you. This is what Europe can do. This is the Ariane 6.2 with the METOP second generation on board, and the Sentinel-5 from the European Commission. And the launch was very late at night, so we were staying at ESTEC at 2:30 when the launch finally was there. And it was a tense moment once again, but this is what you're doing it for. This is what you prepare for. And if you can reap the benefits from all the things that are coming down, it's fabulous. Thank you for your attention.